Okay, grade 9s. So this is the first lesson in our algebra unit. Okay, so there's a few different things that we're going to look at here, and one of them is I can substitute values into an algebraic expression, which is like a formula, and then evaluate to get a final answer. Okay, so that's one thing we're going to do. The other thing we're going to do is I know how to properly reference the mathematical terminology. So every area has its own terminology, words that you would only use in those situations. And for us in math, algebraic expressions, itself and expressions have different meanings. And so we're trying to introduce that because you're going to see these words throughout your math career in high school as well as beyond. Okay, so the first thing is, let's take a look at sorting the following math terms into groups that are the same. So you can see I have some 5s and some 3s, but not all of them are the same. Okay, so if you notice 5, well, has a base of 5 as well, but it's squared, so it is different than just the number 5. So if I go through and put a circle around all of the 5s, oops, 5s, not 5 squareds. Okay, and I'm just cloning it. There's another 5. And it doesn't want to click for me. And is there any more? There's one there. There's another one there. Okay, so I think I have all of just the number 5s. Now we noticed that we also had a base of 5 and it's squared. So they kind of go together as well. Well, not kind of, they do go together. So if I go and put a triangle along all the ones that are 5 squared, okay, there's another one there. Okay, then if I look, I have some 3s. I have some 3s and some 3 squareds. So they're different. They're similar, but they're different. So this time, I think I'll just clone here. I'm going to find all the 3s and I'm going to put a box over them. And I believe I have all of those. So this one can disappear. And then finally, you can see what I have left. They're all 3 squareds. So I'm going to put like a cloud over them. So it's something like matching when you were, especially in the early primary grades, they would get you to sort things by color, by shape. Same kind of thing here. We sorted these numbers by 5s, 5 squareds, 3s, and 3 squareds. Okay. Now, now if I try to write a math statement using order of operations that would make it easier to find the total of all those sums. I could go 3 squared plus 5 squared plus 5 plus 5 plus 5 squared plus 5, and I could do that and I'd be entering an awful lot of things in. So an easier way would be, and I have this actually done for us already, is the number of just 5. So those are the circles. So I have 1, 2, 3, 4, 5, 6, 7. So I have 7 5s. Okay, so I have 7 times 5. And then I could add the 5 squares. So those are the ones with the triangles. And you can see we have 1, 2, 3. So I have 3 5 squareds. And then finally, well, not finally, now if I look at the 3s, I have, the 3s are in the blue boxes here. And so I have 1, 2, 3, I have 4 of them. There's one at the top there. And finally, 3 squareds, the clouds, 1, 2, 3, 4. So I have 4 3 squareds. So now what I can do is I can take my calculator and I literally can go 7 times 5 plus 3 times 25, because I know that 5 squared is 25, plus 4 times 3, plus 4 times 3 squared, which is 9. And when I do that, it's less numbers for me to have to enter into my calculator, and out comes 158. If I had done it separately, 3 squared plus 5 squared plus 5 plus 5, it would take me longer. Okay, so it was shorter to do it this way. Okay, so that's numbers. So what is actually algebra? Okay, so in algebra, really what we do is we put a letter, it's usually an X, but it can be any letter, in place of an unknown number. But almost all operations that we can use with numbers, we can also use with algebra. So for instance, if I have 3 plus 3 plus 3 plus 3, okay, and if I talk about it with algebra, it'd be like x plus x plus x plus x. If I do 3 squared and I have 4 of them, that would be like taking the x and squaring it 4 times. Okay, so you can see that that's roughly what it's looking at. Okay, now you're saying, well, why don't I just put 3 here? Well, I could maybe change it that now I want x to be the number 4. Okay, so this can change these numbers. So that's one kind of way to look at it. So the problem between when I have the 3's and when I have the x's is I can actually take my calculator and actually calculate these, right? So I can literally go and put, well, that equals. So when we have this, we can see that we have 4 3's, so that's like 4 times 3. And obviously I don't need a calculator for that, or I shouldn't. Okay, so that equals 12. And then if I have 3 squared, I have 4 of them, and I know that 3 squared is 9, so really what I have is 4 times 9, which again I can calculate because they're numbers, I know what those numbers are. So we have 36. But then what happens when I have these x's? I can't take my calculator and go x plus x plus x. So what we do is we take these, and just like I had 4 3's here, I have 4 x's. So that's like 4 times x. The x squared's almost the same thing, except I have 4 times x squared. So you can see that they look similar, but they are obviously different. So they're both simplified, okay? Simplifying here means, no, I don't know what that equals unless I tell you what x equals. Okay, so it makes it look more compact. Instead of it taking this much room, it takes this much. Okay, so that is one of the concepts we have to pay attention to. So here's that terminology I was talking about earlier. So the expression 4x, for instance, is called a term. A term in math usually has a number. Okay, in this case, it's the number 4, and it has a special name. It is called a coefficient. Now, a coefficient, and I believe the E should have came first. The coefficient, in most cases, is a number. No, I had it right. Okay, so in here, this is our coefficient. And I also have a letter, and we call that letter a variable. And this is really important. The operation between the coefficient and the variable is always multiplication. Now, sometimes terms can have more than one variable. So for instance, if I have 5x squared y, I have x's and y's, so two different letters, so two different variables. But if you notice, they're all attached together. There's no sign in between them, so that means it's 5 times x squared times y. Now, it's possible that you could have a term that has no variables. So that was what we did at the very beginning. And what we call them, they're a special term. They're called a constant term. Okay, so up here, if I look at what we did up here, we had 4x squared. Okay, so obviously that's a variable term, whereas if I have 3 squared, that's a constant term. Okay, now you've maybe seen on these expressions before. They're called formulas, and formulas actually use variables. They use letters. Okay, and the reason we do that is if we're working with a rectangle, not all rectangles have the same measurements for their sides, but in general what we have is, okay, because not all rectangles are the same, but the formula for finding the perimeter or finding the area is the same. So this is where we're substituting values in. So the example 1 says a rectangle has a length of 15 and a width of 8. Find the area and the perimeter. Well, if I go back up to this formula sheet, I can see the area, which is in the right-hand column, is area equals length times width. Now, what's nice about this formula sheet is it also has the variables in the picture, so that helps me determine if I'm doing it right. So the first thing I would do is I'd write down my formula. So A equals LW. I go back to the question. They say my length is 15. And notice there's no sign in between here, so that means it's multiplying, and the width is 8. So now what we do is we can take our calculator or our brain, and we can calculate that as being 120 centimeters squared. Don't forget your units. The perimeter, there's two different formulas we could use. We could use perimeter equals length plus width times width, or we could use 2 bracket length plus width. And it doesn't matter which one you use. Right now, I'm going to do all the adding of the sides just so that you understand perimeter is the distance around a shape. So I have 15 plus 15 plus 8 plus 8. And again, I could take my calculator. I have 30 plus 16, so I have 46. And this time it's just centimeters. Okay, so we have 2 more kind of questions to do here. Evaluate. So remember evaluate, we saw it in the last unit as well when we were simplifying powers. We were simplifying first and then we were evaluating what they equal. So evaluate means what is the number. Here they tell me that all the x's are going to be -3, all the y's are 4, and all the z's are 2. So equal sign directly underneath. So I have an x here, so where the x is where I'm going to put that number. And I'm just going to put a bracket there, plus 15. So that bracket, because remember it's -2 times x, here our x is -3. 2 negatives make a positive when I'm multiplying, so I have 6 plus 15, which equals 21. Okay, the next one, this time they have 2 different variables. Notice I used a square bracket instead of the round because I'm going to do 3 plus 4, and I am actually replacing the x in this case as -3, and the y they're telling me to use is 4. Now here I have to follow order of operations, so I have to do what's in that bracket first. And what's in that bracket is some multiplication and then some adding. Okay, so 3 times -3 is -9, plus 4 times 4 is 16, and all of that's going to be squared after I add those together. Okay, so you can see we have a stronger positive army, so our answer is going to be positive 7 squared, and to evaluate it, it's going to be the number 49. And finally, here's another one, 2, and where the x is, I'm putting a bracket. It's going to be 2 times whatever the x value is, which is negative 3. And then the y value here is 4. And this time we're going to divide by 3 times c squared. And we haven't used c yet, so c is the number 2. Oh, we don't have any c's. I'm pretty sure this should say z. So I'll put a z there. And back up so I can see, what did I say? It's 2. Okay, so remember I have to follow order of operations. So I have negative 6 minus 12 on the top, and on the bottom I have 3 times 2 squared, which is 4. Finish doing the top, so I end up with that equaling negative 18 over 12. Okay, now this is not a whole number. Remember, mathematicians don't like pulling out their calculator a whole lot, so we just simplify it. The largest number that goes into both 18 and 12 is 6, so I'm going to divide the top and the bottom by 6, and I end up with negative 3 over 2, okay, or negative 1.5. The next question, same kind of thing, except look at the formula this time. Okay, so now I'm going to have to figure out what all those letters stand for. So an airplane accelerates from rest down a runway at 3.2 meters per second for 32.8 seconds until it finally lifts off the ground. The formula, and I won't repeat that, that's the formula there, calculates the distance when v is initial velocity. Okay, now we'll have to figure out what initial means. T is time, A is acceleration. Determine the distance the plane travels before takeoff. Okay, so the D here is the distance. Okay, so that's what we want to find. Now, V is the initial velocity. So that means the starting velocity. What speed am I starting at? Well, it says an airplane accelerates from rest. Okay, that means my V in this case is going to equal 0. Okay, because I have no speed at the very beginning. I'm starting at 0. We also have T is time. That makes sense. And in this question, it's 32.8. And we also have A, which is acceleration. And they tell us acceleration's this. So this formula has quite a few variables in it. So V is 0. T is 32.8 plus 0.5 times A, which remember was our acceleration, which is 3.20. And finally, our T is 32.8, and it is going to be squared. Okay, 0 times anything is still 0, so that doesn't exist at all. And so this is 0, and then when we calculate this, it works out to 1,721 let's say to one decimal place, 0.3. Okay, so what did we just find? We found that the distance that the plane travels, so it's starting at rest and it's picking up speed and then it takes off. So we just found how long it's on the ground. So what's the distance? The distance, remember word question, I expected, therefore statement. 1721.3, and is that kilometers? Probably not. Let's go back. What units did they use for measurement? They used meters. Okay, so what you're going to be doing is you're going to be doing some practicing of these skills. Okay, and I will see you tomorrow. Bye.